Physicists are delving into the mysteries of cosmic strings, ancient relics of the early universe, which they believe may hold the key to unlocking time travel. These structures, formed moments after the Big Bang, could potentially warp space-time and allow for journeys into the past. According to scientists, the universe before the Big Bang was a place of intense heat, density, and energy. When the universe exploded approximately 13.8 billion years ago, a rapid inflation occurred, dividing one superforce into the four fundamental forces we know today. This cataclysmic event also left behind cosmic strings, described as scars within the fabric of space-time, akin to stretch marks on skin or cracks in ice. These strings are incredibly thin, about the size of a proton, extremely dense, and can stretch for light years. While these cosmic strings passively drift through the universe, some physicists propose that actively studying them could uncover secrets about the universe's earliest moments and, potentially, provide a way to travel through time. This idea, though seemingly like science fiction, is rooted in cosmic string theory. Dr. Ken Olum, a research professor of physics and astronomy at Tufts University, explains that if two parallel cosmic strings passed each other, they could create a time machine. He suggests that space-time would be warped, and if someone traveled around these strings, they would return to their starting point at an earlier time. This concept isn't entirely outlandish. The math behind cosmic string-powered time travel has been shown to hold up. However, the realization of such time travel is far from simple. One of the major hurdles is that scientists have yet to actually observe any cosmic strings. In 1991, physicist J. Richard Gott proposed that two infinite parallel cosmic strings passing by one another could create a closed time-like curve, a loop in time where a time traveler could return to their starting point at an earlier moment. This kind of time loop is a proposed solution in line with Einstein's theories of general relativity, which explains how massive objects can warp space-time. Despite the sound theory behind it, achieving time travel through cosmic strings faces serious challenges. Firstly, it would require travel at near light speed, which requires immense amounts of energy. Secondly, the infinite nature of the cosmic strings required by Gott's model make it, according to Olum, not useful for construction. However, some researchers find cosmic strings a more promising path than alternatives such as wormholes. Dr. Henry Tai, an emeritus professor of physics at Cornell University, expressed that time travel is unlikely but not completely impossible. The detection of cosmic strings is crucial for further exploration. The North American Nanohertz Observatory for Gravitational Waves, a collaboration of astronomers using pulsars to detect low-frequency gravitational waves, might be bringing scientists closer to this goal. In 2020, Nanograv observed a signal that did not match patterns of gravitational waves from black holes, which could be a signal from cosmic superstrings. Cosmic superstrings, different from the cosmic strings formed after the Big Bang, are part of string theory. This theory suggests the universe is made of 10 or more dimensions, in which tiny strings replace particles, vibrating at different frequencies corresponding to different fundamental particles. It is believed that string theory strings could have stretched in the early universe to become cosmic superstrings. While more data is necessary to confirm the signal as coming from cosmic strings, new data should arrive over the next few years from Nanograv, with potentially more to come from a space-based gravitational wave telescope named LISA that is planned to launch in 2034. If these findings are confirmed, it could revolutionize our understanding of physics, solidifying string theory as fundamental. This research might just be what's needed to encourage physicists to address the issues in Gott's time travel theory.